This is the 23rd episode of Advanced J1939 for Technicians. In this episode, I'll look at a real problem that occurred with a John Deere S660 combine that I was working with recently. The operator complaints were that the display would sometimes go blank, the data would go blank from the display, that there would be diagnostic trouble codes. Most of those indicated loss of communication with one or more controllers, and that the engine speed would surge when the problem occurred. So I went to the machine, and after the technician had replaced a few controllers on it and was not successful in finding the cause of this intermittent problem, he tried shaking the wire harness around, never could get the problem to reoccur. It was very intermittent. I went to the machine with my Pico scope, and I spent probably 6 hours riding around with the technician, harvesting corn, trying to duplicate the problem and to collect the data. Unfortunately, that 6 hours didn't prove to be worthwhile. We were not able to duplicate the problem. The machine ran for probably 3 or 4 more days with no issue. It obviously hadn't fixed itself. It still had the problem, and the problem started occurring again. So the technician did not have a Pico scope, but instead was able to use the John Deere service tool to collect a can trace. I'm able to take that can trace and put it into a program called Vector Canalizer. I think I've done videos on this before. This is an engineering tool that I've used with several companies in the automotive industry to troubleshoot can problems. So this is definitely probably not a technician tool, but it's a good tool to be able to show this type of problem. So what I was able to do, I could take this can recording that he gave me in a format. Fortunately, the John Deere service tool saves a can trace in this Vector Canalizer format. The engineers who work for John Deere then are able to take that, or people like me, to take that and to load that into Canalizer and to then replay it. So this is exactly what I'm going to do here. I've got this already set up. I'm able to take a parameter such as engine speed because it's a broadcast, we call a broadcast J1939 parameter. So it's a standard parameter. Pretty much every engine manufacturer, it doesn't matter who manufactures it. It could be Cummins, it could be John Deere, Caterpillar, anyone who manufactures diesel engines used in on-highway or off-highway machines should have this message that's available. So I can, the vehicle display that displays the engine speed, the tachometer is able to display this pretty much on any application. So you can see here that the engine speed was held, each of these is a second, so from about 750 seconds to over 1,000 seconds, this was recorded. And as we go along, engine speed is held at 2,200 RPM. The machine then, for whatever reason, increased engine speed to about 2,350. So this was a command from one of the vehicle controllers, probably a cab controller, that would send the message to the engine controller that requests a specific engine speed. This is a proprietary message with John Deere, so I can't decode that message, but I can see where engine speed is at. Engine speed then, whatever this operation was, probably unloading or something here for this period of time. Once that is done, then we dropped back down to about 1,700 RPM, which would be where this engine would be for like probably a medium speed. You can see then that there was some glitch that occurred here at approximately 1,030 seconds. Engine speed dropped down below or close to 1,200 RPM. So the engine controller, if it did not receive a message from the vehicle controller, the cab controller, that was telling it what speed it needed to be at, the engine speed will default. And this happens very quickly. If we look at J1939, if I come over here and we take a look at on our DTC monitor, I can see that during that time, at 1,031 seconds, the engine controller set a diagnostic trouble code that is 2006.9 or .09, and there's been 13 occurrence counts of that. So if you're familiar with standard J1939 diagnostic trouble codes, and most engine manufacturers are really good at following the standards or the recommended practices of SAE. They're not necessarily required, but it makes it so that all of the devices in the industry are standardized. That's the idea. So the engine controller has set this 2006.09 DTC. An FMI, if I were to take this and put this into another format called symbolic format, will tell us that that is an abnormal update rate. And so that's what that failure mode indicator means. We'll go ahead and put it back in numeric because most texts are used to that. The 2000 DTC, if whatever the last three characters of anything that is a 2000 by the recommended practice should be the source address of the device that's missing. So in this case, we have the engine controller. That is source address 0 is missing source address 6, which here is identified as cruise control, but in this case, this is the EIC or the AIC. It's the controller that within that cab controller that is going to tell the engine what speed it needs to be at. So Deere technicians, I'm sure, are very familiar with this DTC 2006.9 or .09. So this is the only diagnostic trouble code that's set when this technician took the CAN trace. He said the problem occurred, it was very brief, and that's all he was able to capture. He emailed me the CAN trace. I was able to then take the CAN trace and to load that into this vector canalizer tool. So looking at that CAN trace, if I looked at the numeric versions of this, you can typically open those CAN trace files in in Excel or any kind of notepad. I have a video that shows you how to do that. One of my other videos, I forget which one it is. But anyways, if we take a look here at the CAN trace, we can see that at 1031 seconds, there's something called the DM1, which is diagnostic message 1. And that is from a source address of the engine controller, and that's going out to all of the other controllers. And here's that actual data that shows that diagnostic trouble code. So if we expand this, which is one of these great things of this $10,000 tool Vector has, I can see that the diagnostic trouble code is 2006, and the failure mode indicator, the SPN is 2006, the FMI is 9. Here's our diagnostic trouble code that was set by the engine, indicating it was not able to see source address 6. One of the things I can do with this tool, and you can do if you put this in Excel or something, is I can go ahead and I can look at source address 6. And let's just take a look to see if source address 6, is it broadcasting? Is it there? Is it present? You might be tempted to say, because we're setting a diagnostic trouble code of 2006.09, the engine controller, I'm going to suspect that my problem is with this source address 6, or that my problem is with the engine controller. And in this case, as we're going to find what our real problem was, it's none of the above. If I'm going to go ahead and change, so instead of the actual time that whatever this was by seconds of when it started, I'm going to change this to where it's the delta time, so the difference in time between messages. So we can see that source address 6 is typically broadcasting at a rate of about 20 milliseconds. And this is typically what this is going to be. So every 20 thousandths of a second, there is a message that is broadcast by this vehicle controller that is telling the engine controller what speed I want you to be at. Here's the proprietary data, because my database has no idea what this is. It's manufacturer specific information. This is Deere's secret information over here, just like any other manufacturer. I have no idea what this data actually means. I would need the secret decoder ring from John Deere. They're probably not going to give me that to be able to determine what this requested engine speed is. I'm pretty sure it's going to be what the actual engine speed is. We could look at that and decode it and see that I'm requesting that. It wouldn't be hard to reverse engineer it. I just really don't have any desire to do that. What I'm looking at here, though, is I had 400 milliseconds, almost half a second, where source address 6 was not broadcasting anything. And in addition, what it's doing here is something called an address claim. And usually you do this whenever something resets. Some device would say, I want to know who's on the CAN network. And so they'll request an address claim. Here's an address claim. We can see here that the manufacturer is John Deere. This is all J1939. In the recommended practice. There's nothing that's proprietary here. This is all defined by Society of Automotive Engineers. And to say, here's my, based on all those numbers, here's who I am. So we can see the manufacturer code over here, this 0432, this is, encoded in that is 21, which means I am John Deere. This is an industry standard thing. Any tool would know, anything that can connect to the CAN bus would know that this is John Deere. There's nothing proprietary here. Some of these other things, it tells us what industry group I am. Well, surprise, it's agriculture and forestry. And what do I do? Well, I'm cruise control. Well, in this case, that's what source address 6 typically is. It's some device that interfaces with the engine controller. In this case, it's to tell it engine speed request. So you can see here, basically from this time until, let's go and put it back in the absolute time format, from 1030.2 seconds to 131 point almost 2, I went almost 1 full second without any messages from the source address 6 that made it to the engine controller. Well, what's the engine controller going to do? The engine controller is going to set the diagnostic trouble code a little later on down, within whatever, 100 milliseconds or so, to say, I can't see source address 6. We'll go ahead and take a look at that again and see what that is. We reset the filter, and let's go to, let's set this to DM1, which is what that's called, diagnostic message 1. And as I showed before here, let's put this on source address 0 just so we can see. It makes it a little easier. So source address 0, we did not have any diagnostic trouble codes up to some point. And as we scroll through this, we can see that at 1027 seconds, there were no diagnostic trouble codes. At 1031.2, about 100 milliseconds after that device started communicating again, we set a diagnostic trouble code for 2006.09. Here is that data. If I look, I can see that that diagnostic trouble code was active for, about 5 seconds. And then here we are back again, showing one message up. We can see that there are no diagnostic trouble codes. So we had about 5 seconds that diagnostic trouble code was active. So if I just looked at this and I tried to troubleshoot this problem based on the CAN data that I have, the CAN data showing me that I have 2006.09, the diagnostic trouble code isn't helping me. I could replace the engine controller, I could replace that cab controller, and I still have this problem. The reason that this is probably appears to be the only diagnostic trouble code that's set for this problem is the engine controller is, as you saw that message, is broadcast every 20 milliseconds. The rule of thumb is if you miss 5 messages in a row, so 5 messages at 20 milliseconds should be about 100 milliseconds or a tenth of a second. In this case, if the engine controller is missing that message from source address 6 for whatever reason for approximately 100 milliseconds, we're going to get this diagnostic trouble code. John Deere technicians are probably very familiar with this diagnostic trouble code because it's probably one of the most hair trigger diagnostics that there are. That's very important, this communication from this vehicle controller. What is the engine requested speed? Obviously, if that controller that's requesting it from the engine stops communicating for any reason, the engine controller really doesn't have much choice to what to do with engine speed other than something like this. I'm going to take it to something that's a safe speed. Obviously, we're not going to take it to to 3,000 RPM or anything ridiculous. I'm going to try to drop the engine speed down to something that would be closer to low idle. And that's what occurred here. And this was the surge in engine speed that the customer's complaining about when the problem occurs. Okay, so back to the CAN trace and looking at all of the controllers during that time period that we're broadcasting. I'm going to go ahead and change this to something called AC, which is address claim, and we'll see what occurred during that time. So you can see about our time of problem was somewhere around 1,030 seconds. So this is each of the controllers. This is whatever this is. This is auto. I think this is like an auto temp controller. This is a cab climate control. We can see each of these is a different controller, and it's going to show who manufactured the controller. Most of these are going to be John Deere, but we can see specifically. I'm going to go ahead and just zero in on this guy. So this is controller D3 in hex, which is 211 in decimal. So this is a device that's manufactured by Ag Leader Technology Incorporated. So this is a moisture module. It's a sensor module that senses the moisture of the material. I don't know. I'm an engine guy, not an ag guy. But this is this device. I just wanted to point out that source address D3 is there on the CAN bus and communicating. If I take a look at, we'll go ahead and put all of the modules here, and I'm picking on D3 because I've got a specific reason for that, and I'll show you that in the data that we collected the next couple of days later with the Picoscope after this. I think it was actually the next day. So if I look at source address D3 during this time, source address D3 is there and communicating, but if I drop this down to the delta time, we can see that I've got a period of time here for about 3/4 of a second that device is not communicating. So this is once again around our same time, about that 1030 seconds, where we had problems. But it's very important to note that that device is there and communicating. I couldn't look at anything here, and as I said, I looked at this CAN trace before I got the Picoscope data to be able to actually diagnose it. All I knew was there was a problem that occurred on the CAN bus during this time based on the diagnostic trouble code and based on what happened with our engine speed, that we had this glitch. We could see that engine speed decreased and dropped down. The engine for the same kind of thing, about 3/4 of a second, wasn't broadcasting. So what I really needed to get was something, I needed to get the data captured on Picoscope or something that's going to give me the voltages levels on that CAN bus to try to determine what's wrong. So we were able to get a Picoscope on this machine and to capture the data when the problem occurred. So you can see here, this looks good. This is a 250K CAN bus. There's my favorite controller, the engine controller, that's broadcasting information. This happens to be that PGN F004, which is engine speed. So this is encoded in this data, is that information. The engine was maybe 1600 RPM, 2000 RPM. I don't know exactly. It doesn't really matter. I could decode it if I wanted to. I really don't care at this point. You can see though on this trace, everything looks fine. We're able to decode everything. If I go to the next waveform here, we can see that something does not look right out in this area, that something has happened, and sure enough, this is our problem. We were able to duplicate our issue. I can't decode this. I can't tell what's wrong, but if you watch my other videos, you're gonna say it looks like there's some problem with CAN high, and that this may be multiple controllers or one controller. Luckily, we're able to get one controller to be able to broadcast the entire message and to then be able to decode that. I set my decoder up because of our amplitudes. I set it up for 700 millivolts and about 300 millivolts of A minus B. I could have just used, I could have done some fancy stuff where I took B and I subtracted something from it. But anyways, I'm able to decode it with this. And if I look here, I can see that source address D3, which is 211 decimal, is that moisture device, that moisture sensor that it's called by Deere, their 3-letter acronym, an AYM module. So this is my problem, is something with this AYM module. I was able to see that it was the only device that looked like this. All the other devices, I've got, you can see CAN high, CAN low looks great. We can see that most of the time that this message is by the other controllers is probably not going to be able to interpret this. And this is what this is right here. We have a long more than 5 bits in a row of one direction, and this is by several controllers. This is an error frame. So in this case, even though Pico can't decode this or didn't decode this, this is an error frame. I can tell by the length of time that the bus is held at that level. So in this case, the Picoscope gave me the information, or I was able to capture this with a Picoscope and then decode it and find that I had a problem with controller D3. We checked the wiring of, checked the CAN wiring of CAN high, never could get this to open. But if we were over in that area, we kind of found that we could kind of pound on it or tap on it, and we could get this AYM controller to act up. So this was our apparent problem on this. Hopefully it's resolved. I haven't heard anything back on it. Hopefully that this replacing the AYM controller took care of this intermittent issue. Maybe one thing to point out here, if we're looking at the scope data, we can see arbitration at work here. So we had up in our priority, so we had our priority, we had some other device, and then at some point, some other controller lost arbitration, and so we're able to then continue communicating this D3. Some controllers may be able to acknowledge this at times, and you can see by the acknowledge bit, everybody apparently thought this was okay. This is just one of these things. It's whenever this device starts stepping on other messages that we end up with a problem. In this case, you can see here, somebody did not like apparently the CRC. You can see what the acknowledge bit looks like. We've got our long error frame here. This is definitely our problem in this case, and we were able to resolve this by replacing the AYM controller. Although Pico's not really a can trace, one of the things that I can do, I'm going to go ahead and get fancy here, and we'll take a look at, we're going to look at a field, we're going to go find ID3 source address, and we're going to say contains the argument of 0, 0, I guess is what it's going to be. And we're going to add that, and we can see that that's all we're going to see here now is anything that's engine controller. I'm going to go ahead and add another field, and we're going to look at the PGN, the parameter group number, and I'm going to say contains the argument, I just know this one, FECA, which is that DM1 message. We're going to add. So here is the diagnostic trouble code that the engine controller is broadcasting as being active when this problem occurred. These were taken on different dates and different places with different tools, but you can see here we've got the same data. We have in the data fields, we have 04, FF, D6, 07, 09, 00. This is the diagnostic trouble code, the active DTC that's being broadcast by the engine controller when this problem occurs that indicates it cannot communicate or is not seeing messages from source address 6. Obviously, source address 6 is broadcasting. The problem is this moisture sensor, this source address 211 D3 hex, is causing communication issues where that message cannot get through. You can see here each of these, we have a time section of, or a time division of 20 milliseconds per division. So this is, if I go all the way across, there is a time of 200 milliseconds or 0.2 of a second. So this is long enough, more than long enough, to interfere with that message that the engine controller is expecting. So because of that communication issue being caused by that source address D3, even though source address 6 is still trying to communicate, because of all of the garbage that it's putting on the CAN bus, that it's causing the CAN bus to be full of errors, source address 6 is not able to get a message to the engine controller within that 100 or so millisecond time period, and we end up with an active diagnostic trouble code in the engine controller indicating it cannot communicate with the cab controller, source address 6, that's trying to communicate with it. So in this case, our diagnostic trouble codes really aren't going to help us. In this case, the CAN trace, even using this very expensive engineering tool called Canalizer, I cannot get the information that I need to be able to diagnose this from a CAN trace. I have to have the voltages on the CAN bus to be able to see what's physically wrong.